Sound. Everything you hear is sound. It can be pleasant or unpleasant, loud or soft, high or low. Sound is made by vibrations, something moving back and forth. Stretch a rubber band tightly between your fingers and pluck it. You can see it quiver and hear the sound it makes. Inside your throat are vocal cords. Like the rubber band, they vibrate, but they are moved by the air that comes past them from your lungs. You can feel this movement if you put your fingers on your throat while you talk. The hum of a mosquito's wings and the rustle of leaves in the wind are kinds of sounds, but when the mosquito's wings are still and the wind dies down, the sound stops. To have sound, there must be movement. You can hear a clap of thunder many miles away or a whisper in your ear. Sound may start from far or near, but it must travel. It can travel through solids like metal, liquids like water, or gases like air, and in any direction. A submerged submarine can radio to land. An aeroplane can radio to an airport, and we talk to one another on telephones over metal wires. Sound moves from the vibrating object in every direction, like the waves you see when you drop a pebble in the water. The waves of sound, like the ripples in the water, move outward in every direction in ever increasing circles. When the rubber band moves forward and back, vibrating, the air molecules around it do exactly the same thing. They are pushed forward by each forward movement of the vibrating object and then return to their original position to start all over again. As they go forward, they move enough to bump into the next air particle, which moves forward and bumps another, and so on until the vibration reaches your ear. Your eardrum is like the drum in an orchestra. When the moving air molecules strike it, there is no air from them to move, so they move the eardrum instead. It vibrates, and the vibrations are changed to nerve impulses which go to your brain. Your brain interprets them as sounds. Sound waves take time to get from one place to another. Light travels 1,86,000 miles in a second. Sound is much slower. That is why in a thunderstorm you see the lightning flash before you hear the thunder, although they happen at the same time. At sea level, when the temperature is 32 Fahrenheit, sound travels at about 1100 feet a second or 759 miles an hour. Sound travels faster through warm air than cold air. It moves faster through the heavy air close to the Earth's surface than through the thin air higher up in the atmosphere. Sound will not travel at all through a vacuum where there is no air. Sound travels about 4 times as fast in water as in air. In some metals, sound travels about 4 times as fast as it does in water. An aeroplane in flight is a vibrating object and it produces sound waves. Suppose an aeroplane is flying at a height where the speed of sound is 750 miles an hour. If the plane is traveling at 730 miles an hour, the sound waves made by its motor are moving faster than the airplane itself. They push ahead of the plane, clearing a path for it in the air. But when the plane travels at 750 miles an hour, its speed is the same as the speed of sound. The sound waves made by the airplane motor do not push ahead but stay right at the front of the plane. The plane is trapped in its own vibrations and shakes violently. This wall of vibrations is the sound barrier. The deafening noise you hear when an aeroplane breaks the sound barrier is because by these vibrations at their greatest turbulence just before the plane speeds up and passes through them. When the plane travels faster than the speed of sound, the sound waves it makes stay behind it and no longer affect the plane. As sound travels, it hits things in its path and bounces back just as a ball might bounce. An echo is made by the return of the sound waves to your ears. When you yell in a large yard with a high fence, you hear your own voice bounced back at you from the fence. In ordinary rooms, sound bounces off the walls, but the trip is so short and fast that the echo occurs while you are still speaking. You can only hear an echo if you are at least 55 feet away from the surface that reflects the sound. Then, if you shout, the sound will travel 55 feet to the wall and 55 feet back, a total 110 feet. Since sound travels at 1100 feet a second, it will make this trip in 1/10 of a second. You will hear the echo immediately after you shout. If you are farther away, more time will pass. Sound bouncing off a distant mountain might take enough time to come back so that you can hear several words. Auditoriums sometimes have a bowl shaped wall behind the stage. When sound from the stage strikes the curved surface, its reflection will be focused on the audience instead of fanning out. Megaphones make sound louder because they concentrate the sound waves towards one direction. A doctor's stethoscope is another way of channeling sound. Sound can be muffled to special materials which absorb the energy of the sound waves are used to soundproof schools and hospitals. The moving air particles are taken into the pores of the material instead of traveling further. Any porous materials such as rugs, plaster, and fibers deaden sound. If you talk from one room to another and some of the sound waves go around a corner, the sound waves have been bent. Sound waves that pass through changes in temperature also bend and change their direction. Two people standing on opposite sides of a bonfire cannot hear each other because the sound waves bend when they go through the heat of the fire. Sound waves travel, they are reflected by things in their path. They can be focused, trapped, bent, and compressed. They also have other characteristics. When a drummer strikes his drum strongly, a louder sound is heard than when he just taps it. The harder stroke causes larger vibrations which make your eardrums vibrate more. Your distance from the sound makes a difference too. As the sound waves travel, they become weaker and the sound becomes softer. To hear one syllable of an echo, you must be at least 55 feet away from the reflecting surface. The dog can hear the special whistle, but the man cannot. Pitch depends on the number of vibrations a sound makes. If the number of vibrations in a second is high, the sound is high in pitch. If the number is low, the sound is low. Middle C in the center of the piano keyboard vibrates 256 times a second. A higher note might vibrate 3500 times a second and a lower note 150 times. Not all sounds can be heard by man. Some are too high. As mentioned earlier, dogs can hear whistles too high to be heard by the human ear because their eardrums are more sensitive than ours. They respond to small vibrations too. When two musical instruments, a clarinet and a violin, play exactly the same tune, one as loud as the other, you can tell the difference between them because of the quality of their tones. This is called timbre. The two instruments sound different because many parts of each instrument vibrate and each instrument sends out a different combination of vibrations. Thank you for listening.